Hey everybody, it's Francis. 421 on October 3rd, 2021. We just got done with a video about a couple of different things, La Palma and the newly announced Grand Comet, Great Comet, Bernardinelli-Berstein. I wanted to come back and make a video because I was asked to, when we look at this comet, is that all we're looking at? In 2019, I was alerted to what is known as a Taurid Swarm event potential. The potential for something called the Taurid Swarm event. The Taurid Swarm event is sort of complicated by nature, but once it's detailed and described out fully, it's pretty easy to comprehend. It's going to probably play a part as we move into watching Comet Bernardinelli-Berstein come into view into the years 2031, 2032, because that happens to tie into the research that I did in 2019 describing when the next major potential could be coming from what is known as the Taurid Resonant Swarm. The Taurid Resonant Swarm is a collection of material that orbits around the sun in and out of Mars's orbit and is associated to the comet 2P Encke. When we talk about the Taurid Resonant Swarm, we talk about material and 2P Encke, and we somehow have, up until now, discussed that maybe 2P Encke is the broken up comet or part of a much larger comet that broke up, and the resonant swarm is of 2P Encke or of the originator, progenitor. The story of 2P Encke is one that began out in the solar system, way out into the Oort cloud. And it somehow was sent on an orbit toward the sun. A very large, very big comet. We don't know how big because we don't really have records of it because it happened a long time ago. But when we compare it maybe to Comet Bernardinelli-Berstein, we can draw some comparisons. The statements from Science Today states that the comet came in from the Oort cloud. They have the ephemeris or orbital tracking of the comet, which details its orbit to stay outside of Saturn through 2031 and on as it comes in and exits the inner solar system. But 2P Encke and the Taurid Resonant Swarm, its progenitor, its original comet, didn't make it. It came in fast and quickly, past Jupiter, past Saturn, past Jupiter, and somewhere in between there and here broke into as many pieces as you can imagine, leaving some bigger pieces and some smaller pieces, 2P Encke being a bigger piece. Now, once those pieces over time regroup, and they regroup because of something called resonance, if there's nothing to stop the pieces from moving forward, they will, over time, displace themselves and arrange themselves in a way in an orbit that's similar. And then you take a large planet like Jupiter, and Jupiter locks it into place, into resonance. It can collect and hold large groups of material together in a particular portion of an orbit ahead or behind the larger object, 2P Encke. So 2P Encke is a comet. When it comes by, we see it. But what's ahead of it is a large collection of material, and what's behind it is a large collection of material, and its orbits over time on occasion interact with the orbit of Earth. So we're going to have to pay attention, because no news about comet Bernardinelli-Berstein mentions anything about it being on a crash course into the inner solar system. This orbit is going to scoot by the Sun outside of Saturn, but we have a lot of activity going on inside of the inner solar system at and about that time, because at and about that time, 2031, 2032, my research showed that would be the time that we had the highest risk of interacting with one side of that Taurid swarm. And each year we have two passages, and we have meteor showers, the Taurids, meteor showers that are associated to these Taurid swarms, and it's dependent on how the orbits of Earth and the material interact. 2031, 2032 is supposed to be a very close call. 2019, it was 30 million miles below us, but in 2031 it's going to be right in around us. So maybe Comet Bernardinelli-Berstein is going to show us something as we are collecting information about large comets coming into the inner solar system. We have one that's intact coming in, going to make its pass over the next 20 years, and we have one that we need to deal with over the next 20 years that has broken up and come into the inner solar system, to which we interact twice a year. The Taurid Complex smoking gun detection of cometary activity highlights why identified and photometrically analyzed 88 members of the Taurid Complex. We found that 67% of the objects with useful data exhibit faint cometary activity. This high percentage supports a cometary origin of the complex. We identified two groups: Hephaestos 169P Neat, associated with Comet Encke. We conclude that the Tunguska asteroid is very probably a member of the complex. Remember, the Tunguska asteroid blew up over Russia.